Hello guys! In this lecture we want to introduce regular expressions that are very useful and important in software engineering. First, let's see why it's important and what is the objective of this lecture. So far, we have used sets like a tool to represent formal languages, and these are actually different forms of representing sets, but we emphasize on the set builder a lot, especially on the pattern part. Yeah. Now, let me ask you this question. Is there any problem with set builder? Yeah, there is a problem actually. They are not practical in software engineering and hard to implement as a program. So, if this is the case, then it is reasonable to look for another way, right? Bottom line is, we would need a practical tool to represent formal languages, and that's regular expressions or regexes. Regular expression or regex is a mathematical tool to represent formal languages. I want to say that regexes, like any other topics in this course, have a mathematical base. Of course, our target would be to represent all formal languages, but like any other tools, regexes have their own limitations, as we will see. Before going further, let me give you a brief history about who invented this regex. This was invented or introduced by American mathematician Stephen Kleene. Yeah, his name, the pronunciation of his name is a little bit different. So it's Kleine. And he is also known for the V star, where V is a set. And we have seen this a lot so far, this sigma star. Yeah, it was the invention of this guy. And as you know, the V star means zero or more concatenation of the elements of the V or whatever it is, yeah, we used as a sigma. In this course, we call this sigma as a star operator, but in other articles, you may see Kleene star or a star closure. For more information, you may refer to this link. Let's look at our big picture of this course one more time for refreshing our mind. As we said before, computer science foundation, which is the theory of the computation, is divided into four branches: formal languages, automata, computability, and complexity. And we went over the formal languages. We finished the automata. But for the formal languages, we said that we will get back to this topic several times during the semester once we got back to introduce the regular languages, and this is the second time that we want to introduce the regexes, because regexes are a tool to represent the formal languages. Okay, now let's get started a new journey with regexes. Let's see what they are. Regexes contain two parts: elements and rules or formal definitions. Let's start with elements. Regexes have only three types of the elements. First is the symbols, and these symbols contains the alphabet that we are so familiar with it. And we also have two more symbols that we will cover them and introduce them shortly. The second part of the elements of the regex is parentheses. Only parentheses. We don't have bracket like this. We don't have curly braces. We have only parentheses. And also we have three types of the operators: plus for the union, dot for the concatenation, and a star that we will talk about that as the star operator. Before defining regex's rules, let me take some simple examples to give you a taste of the regular expressions. So this is a language. It has only one string A, and the alphabet is this, and we are asked to represent L by a regex. Since this is just a one simple string that happen to be exactly equivalent to one of these alphabet, its regex will be so simple. Yeah, R equal to A. And please note that we always use the lowercase r to represent the regex. In fact, lowercase r is a shortcut for regexes. Yeah, we just learned how to write the regex for all languages whose strings are only one symbol. And theoretically, we know that we have infinite languages like this because we have infinite kinds of the symbols, right? Our next example is about the concatenation operator or just dot. We can concatenate the symbols of the regexes that we already know, alphabet, phi, and lambda. Yeah, let me take an example. So our language is a little bit more complicated than the previous one, and we want to represent this language with regex. Okay, before going further, let me refresh your mind. Let's say we have language 1 is just A, and language 2 is just B, and if I ask you what is L1 concatenate with L2, the concatenation of these two, we concatenate all strings of the first language with the second language. In this particular case, it will be just AB. Why I went over this? Because I want to tell you that this AB is in fact the concatenation of two simple language. If this is the case, then I would say, okay, L is AB. In fact, it is the concatenation of A and B. And if you refer to the previous example, the regex for this A that we already know it is A, and dot is just this dot, and this B will be B. So bottom line, the regex of this language will be equivalent to A dot B. Our next example is about the union operator or plus sign. We can union the symbols of regexes. Okay, let me take an example. Now we have a little bit more complicated language. Before going further, let me simplify this language. Can I decompose these two strings as a union of these two language? If this is the case, then the regex for this language, we already know that this is the A dot B, and we interpret the union as the plus sign based on this. And for this BB guys, we already know that it is B dot B. So the regex of this language will be AB plus BB. Our next operator is the star operator, and it means zero or more concatenation. And just recall that we also mentioned that it is called Colony star, a star closure, but we prefer to call it just a star operator. Let me take an example. Okay, before solving this example, let me refresh your mind. What was the meaning of the sigma star? We said all strings that can be made by the symbols of the alphabet, right? So here the alphabet is just A, and if I ask you what is sigma star, then you would say, okay, all strings that we can make with A by zero or more concatenation, right? This is the important meaning of the star, right? It will be lambda, it will be 1A, AA, and so forth, right? How about this language? Do you agree that this language is in fact a sigma star? If this is the case, then I would say A to the n such that n greater than or equal to 0, it is equivalent to A star. Yeah, I wanted to reach this point. Okay. Now let's get back to our question. What is the regex of this language? The regex of this language is, we already know that the regex of this will be A, and we put just a star over it. So it means that the regex of this language will be A star. So one more time, let me interpret and translate it. What is the meaning of A star here? It means zero or more concatenation of this symbol. So A star, in fact, represents all of these strings. Our next example is a little bit more tricky. Instead of starting from the zero, I am starting it with one. So if you enumerate this, you will get A, and so forth. So we don't have lambda. But we learned that A star is zero or more concatenation. And please pay attention, we don't have A plus. We do not have such thing. We do not have, let's say, this thing in the regex. The only thing that we have is a star. So we have to make everything with this star. How can I represent this with a regex? Okay, so it means that at least I have one A, and after that A, it can be zero or more. So do you agree that I would say it is A concatenation with A star? This guarantees that at least I have one A. So one more time, I emphasize here that we don't have such thing in the regex, only a star. Now, let me have a side note here. Here are the different representation of a language. So if this is the raster method to represent this language, we can use the set builder to represent the same language. We may represent the same language with an NFA. And now it is the new thing that we just learned, the regexes. Do you agree that regexes is more compact than the other ones? Probably you would say yes. So here are the benefits that we get when we use regexes. Representing formal language in a more compact way. Yeah, we just talk about that. It's a shorthand for the set builder. It is easier to implement in computer as a program. And also, as you might know, regexes has a huge practical applications in operating systems and programming languages. Now let's talk about the precedence of the operator. So if we have a little bit more complex regexes, then there might be some ambiguity. What do I mean? Let me take an example. Look at this. Which operator has a higher precedence, plus or dot? Yeah, let me be more specific. If plus has a higher precedence, then it should be applied first, and then the result should be applied with the concatenation with the C. But if the concatenation has a higher precedence, then this guy will be correct order of the operations. Okay, so which one is correct? I'm sure most of you guys said this one. Concatenation has more precedence, but you are using actually your elementary algebra knowledge. Yeah, even though your choice was correct, but to be on the safe side, or let's say to be cautious as a scientist, it depends on the definition of operator. Precedence is the response. Yeah, to avoid this kind of ambiguity, let me introduce the order of the precedences. So based on this list, the parentheses, as usual, have more precedence, then star, then concatenation, and at the end, union. So, for example, if we have such thing, then based on these precedences, since there is no parenthesis here, the next one will be a star. So this guy has more precedence, and then the concatenation, and at the end, the union. Okay. So by defining these precedences, we prevent to have such complicated thing that is really unnecessary, right? As you see, this is very similar to the elementary algebra, and fortunately, we have a feeling about that elementary algebra, so we won't have any problem to interpret the precedences of the regexes. From now on, for the simplicity, we may eliminate the dot. For example, we may represent this guy like this guy. So as you see, we remove the dot between A and B. We just finished the first part of the regexes, that was elements. Now let's talk about the second part, that is rules. And it is known as formal definition as well. The first rule is phi, lambda, and all of the elements of the sigma or the alphabet, all of them are regexes. Individually, they are regexes. For example, R equal to A, we notice that it is a regex for this language. And the same thing for the other elements of the alphabet, and also for these two guys that I will introduce shortly. And these are called primitive regexes. The second rule is if R1 and R2 are regexes, then the result of all of these guys produces new regexes. So union or plus, concatenation, a star operator, and just using a parenthesis. And the third rule is if I give you a string and I ask you whether this string is a regex, is a valid regex or not, if we can derive recursively from the primitive regexes, these guys, by finite number of applications of these guys, then we would say, yes, that string is a regex. Let me take an example to clarify what I said. These are the regexes. I repeated here to keep an eye on them. And now the question is this a valid regex? Look at this. Based on these rules, let me start from here. Is A a regex? Yes. Is B a regex? Yes. C, and phi? Yes. And is the BC a regex? Yes, based on this. Is BC plus A is a regex? Yes, based on this. You see? How about the star? Yes, based on this. And how about this part? Yeah, exactly. And as you see, we can apply these rules on these symbols, and then ultimately we find out that, yeah, this is a valid regex. You might ask, okay, so do we have invalid regexes? Yes, look at this one. Is this a valid regex? What is this plus and nothing here? Yeah, you cannot apply these rules and conclude that this string is a valid regex. You cannot do that. Okay? In this section, we want to make a correspondence between the regexes and languages. What does it mean? Yeah, that's what this motivation is going to show us. Let's assume we have this regex, and the question is, can we mathematically calculate that what language this regex is representing? That would be fun and very useful thing, right? So if we have the regex, we need to be able mathematically calculate what language it is representing. So in fact, let's say that L of R is the operator that we are looking for the language for R. In fact, we are looking for the result of this calculation. To be able to do that, we would need some mathematical rules. Yeah, we have these regex rules here to keep an eye on them and try to find a corresponding language for each of them. This is the first one. It means that if regex is equal to phi, then L of R or L of the phi is equal to this language. How about the lambda? Yeah, the same thing for here. I need to mention here that we use these two symbols to be able to represent these two languages. It means that if we didn't have phi and lambda, these two languages couldn't be represented by the regexes. The third one is if we have only one symbol, let's say R equal to A, then how can we calculate what language it was? Yeah, this way. And we had this as an example. What else? If we have this expression R1 plus R2, then L of this is equivalent to L of the first one union L of the second one. So we assume that R1 and R2 are regexes. The next rule is the concatenation. We are here now. L of R1 dot R2 is equivalent to L of R1 dot L of R2. The next one is the parenthesis that it has no effect. We can remove that parenthesis. And last one is R1 star. It can goes to the outside of the parentheses like this. Okay. So the first three are actually the termination conditions, and the last four are for reducing in our calculation to make the expressions simpler. We would need some examples to clarify what we said so far. We will have two types of the practices. Going from regex to language. It means that we have already a regex and we want to find the language. The second practice is going from language to regex. It means that we have a language and we are looking for the regex. Both of these skills are useful in software engineering and we need both of them. Let's start with the first one. It means we have regex and we want to calculate the language. The first example is very easy. So R is equal to B. We are looking for L of R or L of B. Okay, which rule we need to use? Yeah, rule number 3 can resolve this problem. So it means that it is equal to B. So this is how we use these rules and we calculate the language. Of course, it's not the case that always we have such a simple thing. Yeah, we try to take many examples to improve your skills and knowledge about this kind of calculations. So we use rule number 3. The second one is this guy. How can we calculate that? L of B dot A equal to, we need to use rule number 5. It means that L of B dot L of A. And then we will use the rule number 3. This guy will be equivalent to A dot, and this guy will be equivalent to, I'm sorry, this is B, and this is A. And this is just a concatenation of two languages, which will be BA. The next one, yeah, I'm sure that you got what we are looking for. So we need to use this guy and calculate. So since these are the easy, I just show you the response. So how can we use this? Yeah, based on the rule number 4, we separate them as a union, and then we can use the rule number 3 to find all of these, and finally a comma B. If this is the regex, this is the language. Pay attention that we are talking about language, even though it looks like the alphabet, but yeah, this is here is a language. How about this one? Okay, so we are looking for the L of A plus BA. First, we interpret this plus as a U based on the rule number 4, and then we use the rule number 5 to decompose BA to these two languages. And as you see here, and it's a BA, and the union of the A and BA will be this. Yeah, so if this is the regex, this is the language. The next one is the A star. This way we calculate that L of A star. By using rule number 7, we can move this to the outside of the parentheses like this. And L of A is A and the star is A star, right? And we know that A star is equivalent to this language. How about this one? Oh, this is the good one. So that's why I put this here. All right. So let's calculate that. So L of A plus B star, first we need to move this star outside of the parentheses. It will be L of A plus B, then a star here. Okay. And how about this guy? Yeah, based on the previous slides, we know that it is equivalent to A comma B, and we have a star here. All right, A comma B star, we already know that it is all possible strings with 0 or more concatenation of these symbols, and it is equivalent to W such that W belongs to sigma star. So it means that this language is everything, right? And this language, the set builder of this language is equivalent to the everything. This is an important one because many times we are looking for everything, and when we say we need a regex for everything, then we need to remember that it is equivalent to A plus B star. Of course, if the sigma is just A and B, if we have more, then we need to plus them as well. Now let's summarize what we said here. The regex is B, the language is this, and all of these examples. And also we emphasize that knowing this is an important thing because we will be using this from time to time. This is another example. So we still have regex and we are looking for the language. In practice, it's not the case that we always use the calculations, right? After a while, we need to be able, when we see something like this, to be able to write the language. For example, here, if you remember that I said A plus B a star is everything, it means that it is equivalent to W. So if L of R, I am looking for L of R and I want to show it with a set builder, then I would say, hey, this is equivalent to W and this is just an A. So we are talking about this language and we know W belongs to sigma star. This one is saying that AA star, what does it mean? Zero or more concatenation of AA. Okay, here is my understanding. The language, zero or more concatenation of the AA, this is the zero. One concatenation will be AA. Two concatenation will be AA, AA, and I'm sure that you guess what we are looking for now. So even number of the A's. Do you agree that? If this is the case, then L of R will be A to the 2n such that n greater than or equal to 0. Yeah, we already know that this is BB star is equivalent to even number of the B's. Now we have one more B, and one more B, it means that we have odd number of B's. I would say L of R equal to B to the 2n plus 1 such that n greater than or equal to 0. We already know what does it mean, and we already know what this means. Okay, so it's just a combination of both of them. Yeah, I would say L of R equal to, so this is the even number of A's, so A to the 2n, and how about this one? Odd number of B's, not necessarily n. We need to use another dummy variable here, right? Because this star and this star does not guarantee that they are equivalent. Agree? Okay, such that n greater than or equal to 0 and m greater than or equal to 0. So this is the way that we solve these kind of problems, guys. I am gonna stop here. See you in the next video.